So let's look at this example here. Show that f of x equals 1 minus x cubed and g of x equals the cube root of 1 minus x are inverses of each other. Now for this one, we've got to go back to the definition. So from a previous video, I got this from our previous video, we had this definition that two functions f and g are inverses of each other if these two things are true. So for this problem here, to show that these are inverses of each other, all we need to do is take the composite of f with g and the composite with g with f and make sure we get x out of it. So let's go ahead and go through each of these. F of g of x equals, well, here's f of x. We have 1 minus, and then we got to put g of x in there. So we have the cube root of 1 minus x cubed. So there is our composite. All right, and usually, if they are inverses of each other, hopefully they simplify pretty quickly. So let's see, we have 1 minus, and then the cube root of 1 minus x cubed is just 1 minus x. We factor out that we distribute the negative, 1 minus 1 plus x, and we end up with x. So that worked. And now we need to take the composite of g with f, so g of f of x. So in this case, g of x is this cube root, so we have the cube root of 1 minus this, 1 minus x cubed, f of x. So let's see here, we got to distribute that negative, so we end up with the cube root of 1 minus 1 plus x cubed, which then becomes the cube root of x cubed, which is x. So they are inverses of each other. So f of x and g of x are inverses of each other, and we showed it there. So it's not too hard of a problem. Probably the hardest part is just remembering that you have to do these two composite functions to show that they are inverses of each other. Right now, the next thing we're going to look at is this concept of, do all functions have an inverse? And that question, you kind of have to be careful about what's being asked. So if I were to ask, do all functions have an inverse function? Okay. Do all functions have an inverse function? And the answer to this is no. That is not true. All functions do not have an inverse function. Now, a lot of times you'll hear people say, oh, well, does this function have an inverse? And even though they don't put in the word function, they do mean an inverse function. It's kind of just one of those assumed or understood parts of it, that when we talk about inverses, we are talking about a function. But just to be clear, do all equations have an inverse? And the answer is yes. All equations do have an inverse. But really when we get to like this section here and in future sections, we're really concerned about finding a function. So we want the inverse function, not just an inverse equation. Because as I've said in previous videos, working with functions is a lot easier, especially when we get to calculus. When you don't have a function, then the calculus gets a little bit more challenging. So most of the time when we talk about do we have an inverse, we want an inverse function, not just some inverse equation. So the next question is, how do we know if a function has an inverse? How do we know if a function has an inverse? All right, so a function has an inverse if and only if the function is 1 to 1. All right, so we'll discuss here what 1 to 1 is pretty soon. But in essence, well, first of all, there's this if and only if statement. So remember, that's that biconditional statement. That means we can say it one way and we can also go backwards. So if a function has an inverse, then it is 1 to 1. Or if a function is 1 to 1, then it has an inverse. That's what that biconditional statement does for us. So a function has an inverse if and only if it is 1 to 1. So let's talk about what does it mean to be 1 to 1. A function is 1 to 1 if each value of the dependent variable corresponds to exactly one value of the independent variable. All right. Now, I wanted to give the more correct version of this first, because really, dependent variable we say is the y, independent variable is the x, but technically they don't have to be x and y. It can be, t and v or whatever. But anyways, a function is 1 to 1 if each value of y corresponds to one value of x. So let's write that down. Okay. So put this in parentheses maybe. Each y value is associated with only one x value. Yeah, that makes sense. So each y value is associated with only one x value.